lived in San Antonio. Up near it, very like suburb of it for a while. And my parents lived there for a while too. I like San Antonio a lot. Oh, what a great question. The same rules for Q and K and all that stuff are still applicable. No solids. Yeah, no liquids. Only things are gases and aqueous that can go into a Q expression. That's the only two things. Yes. Okay. Great reminder. So let's see what I can throw up here real quick because it is time. But I really, wait a minute, we're in 22. I really need to show you one more equation. Well, tomorrow's Friday, right? No, I really need to show it to you guys today. So maybe not 23 also. I mean, y'all can certainly practice that on your own, but let's look at 22 for sure. Let's 22 for sure, right? I might come back and work some of these other ones the beginning of class Monday, but I'm going to go ahead and give you the equation, this last equation that you know. So we are learning this equation right now that has Q in it, right? Okay. So number 22. We are not under standard conditions. How do I know that? All of those pressures are not 1 atmosphere. Standard gas pressure is 1 atmosphere. None of those are standard gas pressures. So if we are not under standard conditions, depending on what information I give you, this is a way to solve for delta G. Okay. I'm using this way because I'm given in the problem, I'm already told the standard free energy out next to the equation, aren't I? 33.0. I'm told T, 298 Kelvin. And I'm given enough information that I can solve for Q. Ln, natural log, yep. My Q expression is going to be P of hydrogen cubed, right? Times P of nitrogen, just to the first, divided by ammonia squared. Perfect. So you're just plugging in those pressures given in the problem. And then all of this gets plugged into this equation. Right? Like I said, a monkey could do this. Maybe, any of y'all, have I asked y'all this before? Any of y'all watch Futurama? And none of y'all have. Never mind. That's fine. Okay, I got 9.7 rounded to the 10th place because that's where my thing. Did you get it, Loretta? Excellent. And you would round to the 10th place because that delta G standard is to the 10th place, and I'm doing an addition at the end of the day, right? Fantastic. Okay, so again, if you guys are going to practice over the weekend, which I suggest, I mean, you're going to be doing homework over the weekend, so, you know, yes, you are. I have the solution for 23 here. You can practice that. And then now I got the one last equation, okay? Which I'm not going to do an example of today. But I'm going to give you the equation. So if you see something that is talking about what? K. Equilibrium constant K. You at least know what equation to try to use, right? I'm about to share it with you. This equation right here. Standard delta G equals negative RT times the natural log of K. What K? K is for at equilibrium. How many different Ks have we talked about Like this many, 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 this many. Guys, can you solve for K? Any K? Can you solve for any of the Ks that we have solved for this semester using this equation right here? You bet your sweet bippy you can. You don't have to do an ICE table. Just find K. If you have thermochemical data, you can find K this way. You're telling me, Miss Poe, I did all those damn ICE tables and I didn't have to do it? Well, yeah, kind of. Delta G standard. So again, this is just standard conditions. What if you're not under standard conditions? Can you use this equation? No, not really. You ought to use this, right? You ought to use this. But isn't Q equal to K as long as it's at equilibrium? So you could still plug in K values here, right? You could still solve, you could still use K here. It's just you would be finding delta G when it's not standard, right?
So we can use that same reaction. I mean, that same equation. If it's not standard.
If it's not standard, yeah. Mm-hmm. So, but the problem is you guys are going to be, this is what I'm telling you. You guys are going to be given problems where it's standard conditions and I say find K. Standard conditions, find K. Delta G, standard, equals negative RT, natural log K. How does this rearrange? So you solve K. And we're going to bring that negative sign over, right? Yep, there it is, rearranged. Solve for K. This is the exponent of natural number E. Yeah. This is not log base 10, this is E. Because that negative gets moved over to the right. That's okay. Okay, so now you guys can do your homework this weekend. First homework set is due tomorrow night, but it only has the stuff from the first set. It doesn't have this math stuff on. Okay. The second homework set is nothing but this section 16.4. So it's got all the little ways to find delta G. That one is going to be due Monday night. Saw that coming. You now today for lab have a worksheet. So come pick this up. You are absolutely free to go down to the lab and work on this or anything else you want to, or have a great weekend. Okay, it's up to you. This is absolutely required for you to do, right? It's going to be a lab grade eventually one day.
At the end of
Some point. Maybe this weekend. I don't know. Maybe my life can quit throwing so much crap balls at me and I can actually have a chance to grade stuff. This is suggested because on Monday we are starting the next chapter, chapter 17, electrochemistry. We're done with the good chapter. Y'all about to hate this chapter.
That was great. Is it worse than acid base?
It's about electrochemistry. And the first thing that we're going to learn about is redox reactions. And we touched on that in my Gen Chem class a little bit. You may have touched on it a little bit in your class, but I promise you, you did not touch on it the way we are about to touch on it. 17 next week. So here is my suggestion to you is that you review how to assign oxidation numbers to elements in a formula. These are my rules. They're not really just my rules. They're the rules, but this is the way I write the rules out. Here are some for you to practice with. Here are the answers. You're welcome. Not like I don't do stuff like this all the time for you guys. Highly suggested. You guys better come in here on Monday knowing how to assign oxidation numbers to elements when we're writing these equations. You had better come in here Monday knowing how to do this. You come correct, right? Okay. All right, guys. Peace out. Love you. I'm going to lunch.